Hello student, welcome to the second part. I am Professor N.K. Rahate, and in this video we are going to discuss how to draw the stick diagram and by using the Euler path. Okay, so the Euler path, it is used to draw the stick diagram and layout of the complicated circuit, and we have to find Euler graph for the pull up as well as pull down network. Then we find a common path for both the graph. Now the pull up network, it means that a network that is made of only P MOSFET, and pull down network is a network that is made of only N MOSFET. Now to draw the this PMOS and NMOS, that is PUN pull up network and PDN pull down network, we have to follow certain rules, and the rules is listed in the table. It is very easy to by heart this table. Now consider, if we have the N MOSFET and if we have the dot operation, for example A dot B, then we have to make a series combination of A and B. If we have two MOSFET, let's say A and B, and having the plus operation, then we have to connect this MOSFET in parallel fashion. Similarly, for the PMOS, if the given equation having the dot like A dot B, then we have to make a parallel connection. If there is a plus operation, in that case we have to do the series connection of the P MOSFET. Now in this video lecture we are going to implement this particular equation, F is equal to A dot B plus C dot D with this bar. Okay, now this bar plays very important role. I will talk about this in further lecture. Now consider this equation, F is equal to A dot B plus C dot D, and for your reference the table it is given here. Okay, now we start drawing the circuit diagram from the pull up network, and we end the circuit diagram with the pull down network. Now look at the equation, A dot B. Okay, so in the pull up network we have to draw the P MOSFET network only. Okay, so A dot B, P MOSFET dot operation, therefore P MOSFET must be in parallel. Therefore the result we get is A is parallel with the B. Okay, so A dot B, we get this particular result. Then we have plus C dot D, therefore the plus comes here. Now P MOSFET plus we have the series combination, therefore what we have now, this series combination. Okay, so A dot B, this parallel combination is in series with C dot D, means C and D's parallel combination. Therefore for A dot B plus C dot D, we get this particular circuit diagram. Now we have to implement pull down network. So A dot B, and we know that in pull down network we use only N MOSFET. Therefore for the dot operation, N MOSFET dot operation, it must be series connection. Therefore A and B, they comes in series, and for the plus it is parallel. Therefore this series connection comes parallel with the series connection of C dot D. Okay, now look at the next diagram, A dot B. Okay, and with the A dot B parallel with the C dot D, therefore C and D comes series, and this is parallel with the A dot B. Now one more important observation you might see here, the VDD is connected to the very top source of the both P MOSFET. Output is taken in between the P MOSFET and N MOSFET, and the ground it is here at the bottom, which is connected to the source of this N MOSFET. Okay, and this is the standard rule. We have to follow this rule. It is not that we connect the ground here and VDD here. Okay, you cannot take the V out from here or here. It must be in between P and N MOSFET. Next, to find the Euler's path, we break this given circuit into two parts. Baba Kiran jara घेऊन जा ना याला. network, and this is the pull down network. Okay, so the next we have to find out the nodes in the pull up and pull down network, and then we have to implement the branches between the node. Now here I have introduced two new terms, node and branches. Okay, let me clear this. The node is the combination of more than two elements. It means that the combination of source of two different MOSFET, source and drain of two different MOSFET, or let's say the sorry, not the combination, the connection of, okay, the connection of, now look here, the connection of A source and B source with this VDD. Okay, so here we have one node, then A's drain and B's drain, they are connected here, as well as C source and D source. So these four terminals, they are connected here, therefore we have another node here. Similarly, C's drain, D's drain, and this V out, okay, they are connected here, so we have another node here. In the same fashion, we can find the different node for the pull down network. Now consider the nest diagram. Okay, so these are the node for the pull up network, and these are the node for the pull down network. Now the next thing what we have to do, we draw the same node, okay, for our reference. Okay, then between these two nodes, this and these two nodes, okay, what we have, two MOSFET, they are connected in parallel combination. At the left side we have this A MOSFET, at the right hand side we have this B MOSFET. Now once you have all the nodes for the pull up and pull down, now you can start drawing the branches. Now branch is what? It is a line representation of a MOSFET. Okay, now between these two nodes we have A MOSFET is here and B MOSFET is here. Therefore we can draw A MOSFET, that means a line here which represent A MOSFET, another line here which represent the B MOSFET. Similarly, between second and third node, we have two MOSFETs, C MOSFET at the left and D MOSFET at the right. Therefore, a branch C come here and branch D come here. Similarly, for the pull down network, okay, we have these four nodes, and between this node we have these branches. Okay, now once you have the this complete setup, okay, now this setup is known as a Euler's graph for the pull up network, and this particular is known as the Euler's path or the Euler's graph for the pull down network. Now these diagrams are known as Euler's. These diagrams are known as a Euler's graph. Okay, and this one is for the pull up network, and this Euler graph is for the pull down network. Now the next task is we have to find Euler's path, a common Euler's path for both pull up and pull down network. Okay, now how to get the Euler's path? Now consider I have started from this particular node. Okay, now we start from this point. Okay, we trace A, then C, then D, then B. Okay, so you can continuously, without lifting your hand, you can track this path. Okay, A, C, D, B. Okay, so this is one possible Euler's path. Okay, similarly we have, if we start from this path, A, B, D, C. Okay, this is the another Euler's path. Okay, similarly we can find the many Euler's path for this particular Euler graph. Okay, and for this example I have selected Euler graph equal to A, B, D, C. A, B, D, and C, and same path is here, sorry, A, B, D, and C. So this is the way to get the Euler's path. Thank you for watching this video.